Hello everyone. Today I am here with you all with the practice question of chapter number 4, that is quadratic equations. We are already having a video on the concepts of quadratic equations. So if you have not seen, please watch the video once so that it will be easy for you to understand that how to solve questions based on the chapter. The link of the video is given in the description box. From there you can see it easily. So let's start with the questions. The equation which is not quadratic in nature is. So we know that the equation will be quadratic if its degree will be 2. So we need to check for which equation the degree is 2. If it is not 2, that means it is not quadratic in nature. So let's check it out for the first equation. It is your x plus 1 multiplied by x plus 3 minus x plus 7 equivalent to 0. So if we are going to solve this equation, first of all we need to multiply these two brackets. So it will be x multiplied by x will become x square, x multiplied by 3 will be 3x, 1 multiplied by x will be x and 1 multiplied by 3 will be 3. So this is the expansion of this bracket. It is minus x plus 7 equivalent to 0. Now if we will solve it further, it will become x square plus 3x plus x and minus x both can be cancelled. So it will be your plus 3x. Plus 3 plus 7 will be plus 10 equivalent to 0. So we can see over here that the degree of the equation is 2. That's the reason it is a quadratic equation. Now let's see for the second equation. First of all, what we need to do is we need to take LCM for this. So first of all, we'll be taking LCM. It is your second equation. X will be the LCM and this x square plus 2x, all these will be multiplied by x. X square multiplied by x will become x cube. 2x multiplied by x will become 2x square plus 1, it is equivalent to 0. Now if we will multiply 0 and x, it will become 0 only. So if we will solve it further, it will be your x cube plus 2x square plus 1 equivalent to 0. Now over here we can see that the degree of the equation is your 3. That means it is your cubic equation. It is not your quadratic equation. That's the reason this will be your answer. We can check your third equation also if you want. So if we'll be checking it, see 2y multiplied by 3y plus 7, it is equivalent to y square plus 3. If we will multiply these two, so 2y multiplied by 3y will become your 6y square. 2y multiplied by 7 will be 14y. It is equivalent to y square plus 3. If we will solve it further, it will be 6y square minus y square, this we have taken over here, plus 14y minus 3 equivalent to 0. So we can say 6y square minus y square will be 5y square plus 14y minus 3 equivalent to 0. So over here again we can see that the degree of the equation is 2. That's the reason it is a quadratic equation. So your second part will be the answer. Now let's see the second question. Statement A, assertion is 3y square plus 17y minus 30 have distinct roots. So we have already learned in the previous video that if there are distinct roots, the condition will be your discriminant d, that is your b square minus 4ac should be greater than 0. If value of d, that is your b square minus 4ac, is greater than 0, then we are having the distinct roots. If the value of d, that is b square minus 4ac, is equivalent to 0, then we are having the same roots. And if the value of b square minus 4ac is less than 0, then we are having no real roots. So over here it is asked that it is having distinct roots or not. That means for distinct roots, the condition should be the value of d, that is b square minus 4ac, should be greater than 0. Now if we are going to compare this with the standard form of your equation, quadratic equation, that is your ax square plus bx plus c equivalent to 0. So we can see over here that a will be your coefficient of y square is your 3, coefficient of y, that is your b, is 17, and coefficient, your constant term, is your minus of 30. If this is the condition, that means we have found the value of a, b and c. We have to find the value of b square minus 4ac. Now b square minus 4ac will be, b is your 17. So b square minus 4ac, that is your 17 square minus 4 multiplied by a is your 3 and c is minus 30. So over here we can see that this is your positive number. And if this minus and this minus both are, if they are multiplied, it will become positive. That means some positive number plus some positive number will obviously give us a big number, only positive number only. That simply means it is your greater than 0. You can find it out even, but over here directly even we can see that here it is a positive number. And if we are going to add, because minus and minus will become plus, so it will be 339, 49, 36, 360 plus 360. That simply means the value which we are going to get it from here will be greater than 0. That means it is having distinct roots. So first is your assertion is true. Now let's see the statement. The quadratic equation ax square plus bx plus c equivalent to 0 have distinct roots if d is greater than 0. So just now we discussed for distinct roots the condition is the value of d should be greater than 0. That means it is even true. And statement R, that is reason, is the true, means reason for your assertion. It is the reason for the assertion also. That simply means A will be the answer. Option A will be the answer. That means statement A is also true and R is even true, and it is the reason for this, for your assertion. So A option will be the answer. Now the question number 3, statement A, that is assertion, is 2 root 2 is not the root of a quadratic equation x square minus 4 root 2x plus 8 equivalent to 0. So see, we have to check whether this is your root of the quadratic equation or not. If this will be the root of this quadratic equation, that means it is going to satisfy the equation. That simply means if we are going to replace this x by 2 root 2, your LHS part will become equivalent to RHS part. So let's check it out. So we are taking the LHS part of the equation. It is your x square minus 4 root 2x plus 8. Now wheresoever x is coming, we will be keeping 2 root 2. So this will become 2 root 2 square minus 4 root 2 multiplied by, instead of x again I will be keeping 2 root 2 plus 8. If I will be solving it further, 2 root 2 square means 2 root 2 multiplied by 2 root 2. If I will be multiplying these two, 2 multiplied by 2 will become 4 and root 2 multiplied by root 2 will become 2. So 4 multiplied by 2 will be your 8 minus 4 root 2 multiplied by 2 root 2. Again 4 multiplied by 2 will be 8 and root 2 multiplied by root 2 will be 2. So 8 multiplied by 2 will be 16 plus 8. So 8 plus 8, 16 minus 16, that is your 0. It is equivalent to your RHS part. That is your 0. That simply means 2 root 2 is the root of this quadratic equation, because when we are replacing this x by 2 root 2, your equation is satisfying, your equation is becoming true. That simply means 2 root 2 is the root of the quadratic equation. But assertion was 2 root 2 is not the root of the quadratic equation. That means assertion is false. It is not true. Now the statement R is the root of a quadratic equation satisfies it. Yeah, just now we said whatsoever the root of a quadratic equation will be, it is going to satisfy the quadratic equation. That means your R is true and A is not true. So D will be the option which says assertion is false but your reason is true. Now let's see the next question. Find the roots of the quadratic equation x square plus 5x plus 5 equivalent to 0. This is the quadratic equation given to us. We know that we can find the roots of the quadratic equation either by middle term splitting method or by using the quadratic formula. So here two questions we have taken. One will be solving by middle term splitting and one will be solving by quadratic formula. Let's solve this question by quadratic formula. So over here, if we are going to compare this with the standard form of the quadratic equation, that is your ax square plus bx plus c equivalent to 0, we can see over here that value of a, that is coefficient of x square, is 1. Value of b, that is coefficient of x, is 5. Value of c, that is constant term, is 5. Now, how to find the roots of the quadratic equation by quadratic formula? What quadratic formula is your, the roots will be given by the formula minus b plus minus root of b square minus 4ac over 2a. Here we are already having the values of a, b, c. If we are going to replace these values over here, we are going to keep these values in this formula, we will be getting the roots of the equation. So just keep it over here, minus b. So minus of b value is 5. So minus of 5 plus minus root of b square. That is your 5 square minus 4. A is 1 and c is 5 over 2 times of a, that is your 1. So we have kept all the values of a, b, c over here in the formula. So if we will solve it further, it will become minus 5 plus minus root of 5 square will be 25 minus 4 5 is 20 over 2 multiplied by 1 will be 2. So this will become minus 5 plus minus 25 minus 20 will be 5. So that is your root of 5 divided by 2. So over here, if we'll be taking plus sign, so we'll be getting one of the root of the quadratic equation. If we will be taking negative sign, then we will be finding the another root of the quadratic equation. So the roots of the quadratic equation will be, one of the root will be minus 5 plus of root 5 by 2 and another will be minus 5 minus root 5 by 2. These two will be the roots of this quadratic equation. So this is how we can use the quadratic formula for finding roots of a quadratic equation. Now let's see the another question. Solve the quadratic equation for x. The equation is given to us as 4 root 3 x square plus 5x minus 2 root 3 equivalent to 0. Now let's see how we can solve this by middle term splitting. So in middle term splitting, what we need to do is, we need to split the middle term in two parts such that sum of these two parts should be equivalent to your middle term and multiplication of these two terms should be equivalent to the multiplication of first and third term. So what is the product of first and third term? First of all, check it out. 4 root 3 x square multiplied by minus 2 root 3. So product should be root 3 multiplied by root 3 will be 3. 4 multiplied by 2 is 8. 8 multiplied by 3 will be 8 3s are 24. So minus of 24, x square should be the product of the two terms in which we are splitting the middle one. Now let's see over here, we can see the sign is negative. That means how we can get the product of two numbers negative when one of the number will be positive and another number will be negative. That simply means this 5x is to be split in two parts such that one of the parts should be negative and one of the parts should be positive. Now if we want the sum of these two as positive, that means bigger number will be positive and smaller number will be negative. So if we are going to check it out, we can simply say that 5x could be written as 8x minus 3x. 8x minus 3x, if we are going to split it, so 8x minus 3x will be your 5x, and if we will multiply these two, your product will be your minus 24x square. So we will be writing this equation as 4 root 3 x square. This 5x we are writing as plus 8x minus 3x. 8x minus 3x is your 5x only. Minus 2 root 3 equivalent to 0. Now from first two terms we will be taking common and from the second two terms we will be taking common. From the first two, we can see over here 4 could be taken common and x could even be taken common from first two terms. If we have taken 4x common, what is the remaining part over here? It is your root 3 times of x and here it is your 2. So this is the bracket. Now from the last two terms we will be taking common. Over here minus is common and see 3 could be written as root 3 multiplied by root 3. So over here in this term, root 3 could be taken common because 3 is the multiple of root 3 and root 3. So out of these 2 root 3, I have taken 1 root 3 common. So remaining will be your 1 root 3 x minus already I have taken common. So it will be positive sign now, root 3 taken common. So it will be your 2. It is equivalent to 0. You must be knowing that this bracket should be same. If it is not coming same, that simply means we have done something wrong previously. So just check it out that these two brackets should be same. Now this is one of the term and this is one of the term. In these two terms we can take root 3x plus 2 common. The remaining part will be, from this term we have taken this bracket common, so remaining is your 4x. From here we have taken this common, so remaining is your minus root 3. It is equivalent to 0. Now the product of two numbers could be 0 when either of these two will be 0. Right? So if we are going to take this as 0, that simply means if I am taking root 3x plus 2 equivalent to 0, then we can say that root 3x is equivalent to minus 2. This will go over here in RHS part, and value of x will be minus 2 of root 3. This is one of the root of the equation. If I am going to take this bracket equivalent to 0, that means if 4x minus root 3 is 0, in that case 4x will be root 3 and x will be root 3 by 4. This is another root of the quadratic equation. So this is how by middle term splitting we can find the roots of the quadratic equation. So these two are the methods for finding roots of the quadratic equation. Hope it is clear to you how to find by quadratic formula and how to find the roots by your middle term splitting. Now let's see next questions. The roots of equation root of x square plus 15 is equivalent to 8r. So here directly we can see directly it is not given in quadratic formation. Now how we can convert it? Simply we will be squaring both the two sides. Both the LHS and RHS we will be squaring, and if we will square it, it will become root of x square plus 15 whole square. It is equivalent to 8 square. This will be the equation. Now if we will be squaring it, the square root sign will be removed. So it will become yours x square plus 15 is equivalent to 8. It is your 64. So we can say that value of x square is 64 minus 15. That is your x square is 64 minus 15 will be your 49, or we can say x will be square root of 49. If value of x square is 49, what the value of x will be? It will be square root of 49. That simply means it will be plus minus 7. That means roots of the equation will be your plus minus 7. Because 7 multiplied by 7 is 49. That means square root of 49 is 7. We will be taking both the two signs, plus sign and minus sign. Because if we will multiply plus 7 into plus 7, it will be 49. If we will multiply minus 7 and minus 7, then also it will be 49. So the roots of the equation will be your plus minus 7 will be the roots of the equation. So if it is not directly given in the quadratic formula or quadratic equation form, then we can convert it also like this. Now let's see the another question. If 1 upon 3 is a root of the equation x square plus kx minus 5 upon 9 is equivalent to 0, then the value of k is. Now here it is already given to us that 1 upon 3 is the root of the equation. That means if this is the root of the equation, if we are going to replace x by 1 upon 3, it is going to satisfy the equation. So wheresoever x is coming, we will be replacing it by 1 upon 3. So this equation will become 1 upon 3 whole square. Instead of x, we have taken 1 upon 3 plus k multiplied by 1 upon 3 minus 5 upon 9 equivalent to 0. So if we will solve it further, it will become 1 upon 3 square will be 1 upon 9 plus k upon 3 minus 5 upon 9 equivalent to 0. Over here we can see, we can make the denominator same also first of all. So if we will be making the denominator same, it will be 9 will be the LCM of it. It will become 1 plus 3 multiplied by 3 is 9. So 3 multiplied by k will be your 3k minus 5. It is equivalent to 0. Now 0 multiplied by 9 will be 0 only. So we'll be solving the numerator part only. 1 minus 5 will be your minus of 4. It is equivalent to 0. We can say 3k is equivalent to 4, or the value of k will be 4 upon 3. So if the value of k will be 4 upon 3, then the roots of this quadratic equation will be 1 upon 3. So this is how we will be solving. If it is given that it is the root of the equation, that simply means it is going to satisfy the equation. Let's see another question. If x is equivalent to 2 upon 3 and x is equivalent to minus 3 are roots of a quadratic equation ax square plus 7x plus b is equivalent to 0, then find the values of a and b. So over here again what we will be doing is we will be comparing this equation with the standard form of the equation. That is your ax square plus bx plus c equivalent to 0. If we will be comparing it, what will be the values of a? That is coefficient of x square, it is a only, same. Value of b is 7 and value of c is your b. So these are the values of a, b and c. Now see if this is given that these two are the roots of the equation. We already know that if it is a quadratic equation, so at the max we could have two roots only. And if these two are the roots of the quadratic equation, suppose this is your alpha and this is your beta. So sum of the roots we have already learned that for a quadratic equation, if we are having the roots, then the value of sum of roots is minus b by a. Minus b by a over here, if we will see, the value of b is 7. So it will be minus 7 over a. This is the value of sum of roots. And product of the roots will be c by a. And value of c over here is b. And value of a is a. So by the quadratic roots, we are having the roots of the quadratic formula, quadratic equation, we are already having the roots. So by the formula, we can find it out that alpha plus beta, that means sum of the roots will be minus b by a. We know the values of a, b and c from here, and values of the product of the roots will be b by a. Now these are the sum of the roots and this is your product of the roots. Now we are already having the values of alpha and beta. If we will be adding these two, alpha plus beta, so it will be 2 upon 3 plus minus 3. We have taken the value of alpha as 2 upon 3 and beta as minus 3. From here we will be finding the values of alpha plus beta. From here we have found the values of alpha and beta, and then we will be equating it. So from here what the value of alpha plus beta will be? 3 will be the LCM. It will be 2. Minus 3 multiplied by 3 will be minus of 9. It will become minus 7 by 3. This is the sum of roots. That is minus 7 by 3, and this is even the sum of the roots. That means we can equate these two. This minus 7 by 3 will be equivalent to this minus 7 by a. It is equivalent to your minus 7 by a. That simply means the value of a will be 3. We can cancel minus 7 and minus 7, and the value of a will be your 3. Now here we will be multiplying these two roots of the your quadratic equation, that is your alpha beta. Value of alpha is 2 upon 3 and value of beta is your minus 3. These 3's are going to cancel. So value of alpha into beta will be your minus of 2. And this will be equivalent to your b upon a, because product of the roots by the coefficients we have taken it as b upon a. So it will be equivalent to your b upon a. By two methods we have found the value of sum of the roots and product of the roots, because we were already having the roots. So we have added it and we have multiplied it. So directly by this method we have got the sum of the roots and product of the roots, and by comparing the coefficients of the equation we have found the sum of the roots and your product of the roots. Now we can equate these two because these two are the same. For the same equation we have found it out. So if we are going to keep the value of a 3 over here, we will be getting minus 2a will be your b and b will be your minus 2 multiplied by a is 3. That simply means value of b will be minus of 6. So this is how we can find the values of a and b, because over here already we were having the roots and equation was given to us. If we are having the roots, we can find the sum of the roots, we can find the product of the roots, and from here we have got the values. Again we have compared the coefficients of your quadratic equation and we got the values of sum of roots, that is minus b by a, and product of the roots, that is c by a. From the equation we have compared this equation by the standard form of the equation and we got the values of a, b, c from here. Now if we are going to equate these two values, we will be getting the values of a as 3 and value of b as minus 6. Let's see another questions. If x is equivalent to k be a solution of the quadratic equation x square plus 4x plus 3 equivalent to 0, then k is equivalent to minus 1 and what else? That means one of the value of k is already given to us. We have to find the another value. And it is given to us that x is equivalent to k is the solution of the quadratic equation. If x is equivalent to k is solution of this equation, that means we can replace x by k. It is going to satisfy the equation. So if we are going to replace x by k, this equation will become k squared plus 4k plus 3 equivalent to 0. Now we can see it is a quadratic equation only in terms of k. We can solve either by middle term splitting or we can solve either by your quadratic formula. So let's see if we are going to solve it by middle term splitting, how we can write 4k as we have to divide 4k into two parts such that sum should be your 4k and product should be your 3k square. So we can write this as k square plus k plus 3k plus 3 equivalent to 0. If we are going to add k and 3k, we will be getting 4k. And if we will multiply these two, k multiplied by 3k will be your 3k square. Now from the first two terms, we will be taking common and it will be k could be taken common from first two terms. Remaining will be your k plus 1. From here we have taken k common, so remaining part will be k. Over here already we have taken k common, so it will be plus 1. Now in the last two terms, it will take common, plus 3 could be taken common. And remaining will be, from here we have taken 3 common, so it will be k is the remaining part, and here 3 already we have taken common, so it will be your plus 1, it is equivalent to 0. Now this is one of the term and this is one of the term. In both the terms k plus 1 is common, so we will be taking k plus 1 common, and remaining over here in this will be your k, here it will be your plus 3. Now the product of the two terms is coming equivalent to your 0. Now if how it is possible, either this will be 0 or this will be 0. So if I am taking first condition, k plus 1 is 0, in that case value of k will be minus 1. It is already given to us that one of the value of k is minus 1. Now from the second bracket, if k plus 3 is 0, so we can say k will be minus 3. So another value of k will be your minus 3. This is the answer. Let's see another question now. The sum of squares of two consecutive natural numbers is 41. Represent this situation in the form of quadratic equation. So see, whensoever we are talking about consecutive numbers, consecutive natural numbers, so if one of the number is x, the next number will be your x plus 1 always. See, if I am talking about 4, the consecutive number of 4 is 5. How we get the value of 5? We have added 1 in 4 and we get 5. Similarly, if I am going to talk about the consecutive number of 10, the consecutive number of 9, it is your 10. So how we get the value of 10? If we have added 1 in it, we got your 10. That means if one of the number is your x, the next consecutive natural number will be your x plus 1. So it is said that the sum of the squares of two consecutive natural numbers is 41. So square of this plus square of this is 41, it is given to us. So how we will be writing it? X square plus x plus 1 whole square, it is equivalent to 41. Now we will solve it further to make it in the form of quadratic equation. See, it is your a plus b whole square, and we know that a plus b whole square is your a square plus b square plus 2ab. So we will be expanding it as a plus b whole square, where the value of a is your x and value of b is your 1. So expansion of this will be a square plus b square plus 2 times of a into b. That means 2 times of x multiplied by 1, that I am simply ignoring because if I am going to multiply it by 1, it will be 2x only. It is equivalent to your 41. So we have expanded this x plus 1 whole square as x square plus 1 plus 2x. Now we will be solving it further. So x square plus x square will become 2 times of x square plus 2 times of x plus 1 minus 41 equivalent to 0. This 41 we have taken in the LHS and changed the sign. Further, if we will be solving it, it will be 2x square plus 2x minus 40, it is equivalent to 0. Plus 1 minus 41 has become your minus 40. We can see over here that 2 could be taken common. So if I will be taking 2 common, this equation could be written as x square plus x minus 20, it is equivalent to 0. Because 2 cannot be equivalent to 0, that simply means your equation is x square plus x minus 20 equivalent to 0. So this is how we can represent the given situation in the form of your quadratic equation. Now let's see the last questions. Find the value of k for which the quadratic equation, that is k minus 12x square plus 2 multiplied by k minus 12x plus 2 equivalent to 0 has equal and real roots. So we had discussed that for equal and real roots, condition should be on d should be equivalent to 0. What d is? It is your value of b square minus 4ac. That means for equal and real roots, the value of b square minus 4ac should be equivalent to 0. Now see over here, this is the equation given to us. If we are going to compare this equation by the standard form of the quadratic equation, we can see that the value of a, that is coefficient of x square, is k minus 12. Value of b is, that is coefficient of x, is 2 multiplied by k minus 12, and value of c, that is constant term, is your 2. These are the values of a, b and c, and for the condition given, that means for equal and real roots, your b square minus 4ac should be equivalent to 0. Now let's see, now find out the value of b square minus 4ac and equate it equivalent to 0. We know the value of a, we know the value of b, we know the value of c. If we are going to keep these values over here, this will become b square, that means 2 multiplied by k minus 12 whole square, this is your b square, minus 4, value of a is k minus 12 and value of c is your 2. It should be equivalent to 0. Now if we will solve it further, it will become, square of 2 will be 4 and its expansion will be your a minus b whole square. So if we will be multiplying it, first of all I am taking this square of 2 as 4 and expanding this a minus b whole square. So a minus b whole square, over here a is your k and b is your 12. So a square plus b square, that is square of 12, 144, minus 2ab, 2 into k into 12, that is minus 24k. This is the expansion of this bracket. Now minus of 4 multiplied by 2 will become your 8, k minus 12, it is equivalent to 0. Further we'll be multiplying it. So this equation will become 4k square plus 4 is 16, carry over 1, 4 16, 117, carry over 1, 4 and 1 5, 576 minus 4 is 16, carry over 1, 4 8 and 1 9, k, minus 8 multiplied by k will be 8k, minus will become plus, 12 multiplied by 8 will be 8 2s are 16, carry over 1, 96, it is equivalent to 0. This is the equation. Now if we will solve this equation further, we will be getting 4k square, this minus 96k and this minus 8k. This will become your minus of 14, 4 carry over 1, 104k, and these two plus 6, 12 to carry over 1, then 10, 17, 7 carry over 1, 607 to equivalent to 0. So this is the equation formed. Now from here we can see that 4 could be taken common from all these. So if we will be taking 4 common, this equation will become k square minus 4 2s are 8, 4 6 is 24, k plus 4 1 4, 4 5 20, 4 6 4 7, 6 are 24, 4 8 are 32. It is equivalent to 0. So this is the equation now. Now because 4 cannot be equivalent to 0, so your further equation will be your k square minus 26k plus 168 equivalent to 0. Now we can solve this equation. We have to find the value of k from here. So middle term splitting we can do even. So what we can do in middle term splitting, that means we have to split minus 26k into 2 parts such that your product should be positive. Product will be positive when both the numbers will be negative. Then only product could be positive. So this could be splitted into your k square minus 12k minus 14k. Sum of these two, minus 12k and minus 14k, is your minus 26k. It is your product is your 168k square. So plus 168 equivalent to 0. From the first two terms we will be taking common. So k could be taken common, remaining will be your k minus 12. From the last two terms we can take common now. It will be minus of 14 and it will be k minus 12. It is equivalent to 0. If we will solve it further, from here k minus 12 could be taken common, and from here also k minus 12 is common from both the two. So it will be k minus 12 we have taken common, remaining will be your k minus 14 equivalent to 0. Now either this bracket will be 0 or this bracket will be 0. So first of all I am taking, if k minus 12 is 0, value of k will be 12. This is one of the value of k. And if another bracket, that is your k minus 14 is 0, value of k will be 14. So the two values of k for which this equation is satisfying, you are having equal and real roots, that is your k is equivalent to 12 and k is equivalent to 14. If the value of k is either of these two, this equation will have equal and real roots. That means value of b square minus 4ac will be 0. Now let's see the last question. Find positive values of k for which quadratic equation x square plus kx plus 64 equivalent to 0 has real roots. Now again the condition for real roots is value of d should be greater than equivalent to 0. The value of d, that is b square minus 4ac, should be either greater than or equivalent to 0. In that condition your quadratic equation will have real roots. Now over here again, if we will compare this equation by the standard form of the quadratic equation, we can see the value of a is coefficient of x square is 1, value of b is coefficient of x is k, and value of c is 64. These are the values. Now find the value of b square minus 4ac. We will equate it. B square minus 4ac, it will be, value of b is k, so k square minus 4, value of a is 1 and value of c is 64. This is equivalent to, not equivalent to, it is greater than equivalent to 0. Value of this should be greater than equivalent to 0. Now if we will solve it further, it will be k square minus 4 is 16, 6 carry over 1, 6 4 24 and 1 25. It should be greater than equivalent to 0. So we can say that k square should be greater than equivalent to 256. Now it is given that we have to find the positive values only. So because if k square is 256, k will be square root of your 256. So here what we will be doing is k square should be, it is k square is greater than equivalent to, so k will be greater than equivalent to your root of 256. That simply means k should be greater than equivalent to your 16. If it is your 16, in that case, see over here we have to consider only the positive values. So we will be ignoring, because it will be plus minus 16. So we will be ignoring this negative sign and we will be taking value of k should be greater than equivalent to your 16, because negative sign is to be ignored. It is already asked that you have to find only the positive values of k. So we will be taking only the positive value of k, that is your 16. That means k, value of k should be greater than equivalent to 16. In that case, this equation will have real roots. This is all about from this chapter, questions about from this chapter. Soon we'll be coming with more videos from other chapters. Important questions we'll be taking from other chapters also. Hope you are liking the videos. If you have not yet subscribed my video channel, please do subscribe it. Thank you.